Kirchhoff.
Who's this Kirchhoff?
Yeah, I believe he's a Russian, although I'm not 100% sure.
Yeah, Sheffield brother.
Who's? In fact, I think there might be two O's in his name, or two F's. I'm not sure. I'll have to check that for you. Hang on. Whoops.
It's not important.
Oh, it is important to get the person's name right.
No.
Sorry, there's two F's in his name. Two F's.
And two H's.
Yeah, and two H's, yeah. Because he's just that important. Yeah. Two F's as well. Yeah, I know. I typed it wrong. Two F's. It's my problem. I have many problems, yes.
It's Friday the 13th.
Is it? So it is. The date. The date is Friday the 13th. It's an unlucky day. What's the Chinese unlucky number?
4.
4. Yeah. So in Europe, it's Friday 13th, which is today.
We have here holiday names Happy Friday.
Ah, no, I know what she's talking about. That's in March.
Yeah.
What's
Good
that?
Friday.
What's that Good Friday?
It's a religious holiday.
It means we have a holiday.
Yes. Jesus holiday. Yeah. Good Friday, but don't worry, that's very far away now. Yeah, your next holiday is Christmas.
Yes.
Yes. Okay, you got his name? Kirchhoff? Two F's. Okay, now, firstly, so basically it comes down to this. He has two laws, and these laws are very, very useful for circuits. So Kirchhoff's first law, it's also called the Junction Law. Write this down. There's no rush. We'll take this nice and steady.
No.
No. Yeah. Okay. So you don't, before you write all of this down, let me explain what it means by drawing it. So what Kirchhoff's first law says, when you have this situation, like this here is current I1, and then it splits into I2 and I3. The charge here is the same as here and here.
Charge.
Yeah, the current in coulombs or in amps. Yeah. So this is going in and these two are going out. So his law says I1 minus I2 minus I3 equals 0. It's the same thing as saying I1 equals I2 plus I3. That these two added together equals this one.
But you said they are the same. I1.
No, that's
On the charge, sorry.
No. That's the voltage.
What?
In parallel, the voltage is the same.
Now we just say here. I1 is equal to.
No, I2 plus I3.
Okay.
So these could be different.
What did I mistake you said yes?
Oh, did I?
Yeah.
Well, no, sorry. When I said the same, I meant this is the same as this, is what I meant. So what I mean is what goes in is the same as what comes out. Input is equal to output for the current. So anyways, that's the idea. But as a formula, it's written like this. That if you add up all the currents, you get 0. But just remember what I did here. The ones that go in, I call plus. And the ones that come out, I call minus. Add them together and the total should be 0. This is Kirchhoff's first law.
Should I write that down?
The whole thing, because this is asked in the exam, both the English and the formula. Now don't panic, he only has 2, okay? So this is the first one.
Write that down?
The whole thing. I for current. And the small I just means like I1, I2, I3.
What's not?
Means junction or point. You got that? Yeah, so I already did that. Yeah. Got it? Keeping her cool?
Yeah.
Yes. Got it? No.
Yes.
Yes. Now, I didn't say, but the reason for this is because the charge is conserved. You should write this down. What that means is what the charge doesn't change. So the charge you have going in equals the charge you have going out. Okay. Second law? Second law? Kirchhoff Second Law, also called the loop law.
Kirchhoff Second
Okay, ready? So his second law, I can explain it by drawing it first, but I'll draw it here. So this is Kirchhoff's second law. I'll draw a simple example of it. So I'll call this R1, this I'll call R2, and this here is a battery. I'll just call this battery here V3. If I put a voltmeter here, I'll call the voltage V1, and if I put it here, I'll call the voltage V2. And what Kirchhoff says is if you take this voltage, it should equal this one plus this one. But you kind of know already that the voltage here, for example, was 5 volts, and if this one was a 3, then this one here needs to be a 2. So you can also write, like with current, you can say V3 minus V1 minus V2 equals 0, or another way of saying it is V3 equals V1 plus V2.
So now, if I go and make a law saying minus 2 plus 2 is equals to 0, you call it kg's law.
But firstly,
Again,
firstly, that's a useless law. No, I'll need to name a law after you. KJ's law. Students which annoy their teacher tend to get punched in their face. Or maybe more like the more you annoy someone, the harder you get punched. And it can be proportional as well. Directly proportional. Annoyance on the x-axis, force of punch on the y-axis, and steadily increases. And we need a fancy name for it. KJ's law of...
Retribution.
Yes, I like it. Yes.
What?
Retribution means like revenge, payback. Good. You make sure you write that down somewhere, okay? All right. So, just like with the current, what you get at the start must equal what you use up. Or if you go plus with what you provide, like a battery or a cell, and then the minus is what you use with the resistors. So the reason this works is because the energy is conserved. What that means is the energy the battery gives must equal the energy the resistors use. So anyways, if you want to write the law down, you can't see?
No.
Because of me. Oh yeah, no, sorry, don't need KJ's law. Sorry, we'll get rid of that now. Right, oops.
Energy is conserved.
The other page.
Yeah, I'll go back to it now. I don't know if anyone needs to write anything here. So the law itself is like this.
The name.
This is a loop. See this? It's a loop. Doesn't have to be a circle, it could be a square.
Ah.
Yeah. Got it?
No.
Are we just waiting for... No, we're waiting for a few people. Some days we're waiting for Grace, sometimes we're waiting for Amanda, sometimes we're waiting for Fahad. It's always somebody different.
Never me.
One day, don't you worry, KJ. One day we'll be waiting for you. Okay, you have this?
Yes.
Yes? Okay. So, I want to say something worth saying again. Don't forget,
Don't forget.
you can still use this formula with Kirchhoff. In fact, this formula is very important when you use it with the loop rule. So, in other words, that formula we did earlier, V equals IR, it's still a very important formula. Even with these formulas, it's still very important. And in fact, you usually need this formula with the loop formula. The loop formula being, remember, this is the loop law. So in other words, the loop, I mean, what do you need in the loop? What's this? V. So if you don't know the voltage, you can still use this formula to find it, is what I'm saying. If you don't know the voltage. So it's still a useful formula. Okay. So that's the first. You don't need to write these down, or if you want to make 1 or 2 points, you can make those. The second point I want to say is that usually for our problems, usually, not always, but usually we only need to use the junction rule once, usually. Yeah, in fact, when I think about the exam, I mean, I think for the exam, I think all the questions, it's only once, the junction rule. However, the loop rule, you often need to use it more than once. Usually this needs to be used twice for problems. Okay. Now these are just general points. They're not rules. If the loop goes the wrong way through a battery or a resistor, then the voltage increases. So remember what I said, if you put the battery the right way, what happens? The voltage increases. But if you put the battery the wrong way, what happens? The voltage decreases. So what happens when you go through a resistor? You lose voltage, but if you go through it the wrong way in the formula, you gain voltage. Don't worry, I'm going to explain all of this with an example as well, okay? And also the loops, you can choose any loop you want. It can be any loop in the diagram. It's easier for me to use a loop that has a battery or a cell in it, and I always like to start with the battery and go with the flow. Now you don't have to write any of this down, but I want to have this on the screen, so if you watch the video again, you can maybe review it. But let's have a look at an example, how to use these. Okay, so really it comes down to examples here. And an example is definitely needed. Okay, so here's my circuit. I have a 5-volt battery, 5-volt cell, with 1, a 2, a 3, and a 4 ohm resistor. So first draw this, please, for me. Okay, did you draw it? Yeah? Yes? We're waiting for nobody?
Yeah.
Finish? Okay. Alright. What resistor was up the top? 1 ohm, okay. And here was 2, and here 3, and 4. And then there's a battery here, and this battery is 5 volts. Yeah. Now, what you can do first is draw the current. So if I start the battery, there's a current here, I'll call it I1. And it goes along, but then what happens when it gets here? It divides into 2. So I have my current, and it splits. So some of it goes to the left, and some of it goes up. So I'll call the one that goes up I2, and the one that goes to the left I3. Does that make sense so far?
Yes.
Yep. And then the I3 continues along, it continues along. So this is still I3 and I3. And then here, it continues along. And then what happens up here? It joins back and becomes I1 again. Yes? Okay. So let's use Kirchhoff's Junction Law. If I look at this junction, what is the current that's going into the junction? I1, I2, or I3? What is going into the junction?
One.
And what is leaving the junction? I2 and I3. Oh, jeepers. I1.
What's the question? What do you want here?
Find all the currents and all the voltages.
Okay.
happens if I use the junction law again? Remember I said you usually only need it once? Well, this is the reason. Let's see what happens if I try to use it again. So if I use it up the top, what's going into this junction? I3 and I2. And what's coming out? I1. Now why is this formula no help?
Because it's the same thing.
It's the same as this one. So this is no help. So we don't actually need to use it. But I wanted to show it to you anyways. So that's the first law. It is the the junction law. So notice, how many things do I not know? I don't know I1, I2, or I3.
No,
Yes. How many formulas would I need to find I1, I2, I3? I should need 3. And I only have 1. So I need the junction rule twice. The loop rule twice. Now if I look at this, I'll show you in grey here. How many loops could I make? I could actually make 3 loops. I could go here and around like this. Sorry, I use a different colour. You don't need to draw this loop. I'll just show it to you. I could start here and go around. That's 1 loop. Or I could start here and go around. That's a 2nd loop.
The third one.
And in fact, the 3rd one I can just go around the edge.
Okay.
Yeah, remember I said you can make any loop for his law.
Okay.
You remember that?
Yes.
But what was my advice? I usually choose loops that have a cell. So I won't choose this one. I'd like to choose loops that have a cell. So what I'll do is I'll choose this loop and I'll choose this loop. 2 loops. Huh? And I'll go positive to negative.
Okay.
Okay. So let me show you how Kirchhoff's second law works. Are we looking? Yeah. So imagine I start at the battery. Which way should I go? Up or down? I should go with the flow. So I'll go down. Question? No. So what voltage is the battery providing? 5 volts. And then what you do is you continue along, and then what happens here when I hit this resistor? I lose voltage. How much voltage do I lose? Do I know the voltage here? No. But I have this formula, I or. What does I equal? I2. What does or equal? 2. So I could say V minus 2I2. Then when I get here, what's the voltage here? What's the voltage here?
I.
What is it?
I.
I what?
I1.
No, that's a 2 there.
One.
This one.
Yeah,
I2. Minus 1 I2. Because I can use this formula again. And what should this equal? It should equal 0. Now let's try the second loop. So again I start at the 5. So let me write down 5. And I go across and I go down. What happens here? How much voltage do I lose? Minus 3 I3. Then I continue. Minus
I3.
4
I3.
I3 should equal 0. Because then I finish by going back to here.
And the last 2?
I have enough. This can be equation 1, 2, 3.
It's okay.
It's all you need. You've made enough equations. Oh wait, why did I write I3 here? Yeah, no, they're both I3. Yeah, that's right, yeah. Now this one is very nice because this one can give me I3. Here I can get I3 is equal to 5 over 7 amps. And then here, I can say I2 equals 5 over 3 amps. And then I can use this formula here to get I1. I1 equals 21, 50, I don't know. 5 over 7 plus 5 over
50
3.
21.
Yes, great. 15 over 50 over 21 amps. So now I know I1, I2, and I3. Because I know the I's, I can also know the voltages by using this formula. So for example, how can I get the voltage here? Let me call this voltage V. What's the formula? V equals I or, what's the I here? I3, isn't it?
I3, yeah.
Which is 5 over 3. And what's the or? Down here? 3. So what's the voltage? 5.
No, I3.
No, I3 is, oh sorry, 5 over 7. 5 over 7 times 3, which is 15 over 7 volts, for example.
Excuse me?
Yeah.
On the first formula, I1 minus I2 minus I3, how did you get 50 over 21?
I put the value for I2 and I3 into the first formula to get I1.
Okay.
Question? Okay. Another example?
If you add all the voltages together, are they going to give you?
No, they won't.
They don't give you 5.
And they shouldn't. Because this circuit is in series and in parallel. KJ, if it was a simple series circuit, then add up to 5, but there's parallel parts here. I believe if I just add the voltages here and here, it should make 5, if I picture this correctly.
And the voltage, please? Voltage equal?
Oh, V equals I or.
Yes.
So I did this one as an example.
Yes, 5 plus
Yeah.
2.
But you have the voltage 5, right?
No, that's just for the cell, not for each resistor. Question? This one? This is the loop. I think it was the, which loop was that one? It was the top loop? Yeah. I made this one here by going around like this. The top loop. I'll do another example. Yeah? I'll make up an example.
And this is the voltage, only voltage 1 for the R1.
Oh yeah, because it's easy to get, it's just V equals I or. So because I know all the currents, it's easy to get. Look, I'll do another example. Can I scroll down? Yes?
Yes.
Like, here's one. This resistor is 10 ohms. And let's connect it to one cell here, which is, let's say, 10 volts, and one here.
Whoa.
Never relax, KJ. Stay calm. Five volts.
So we have to add them to get to...
Oh, let's make it interesting. Let's add in another battery. Let's stick one right here and make it a big fat 20 volts.
And always you connect them in series?
Could be anything. Could be anything.
No, I mean the resistance R.
No, could be anything.
Anything.
Parallel series, upside down, anything. Ready? Yeah, so the first step is to draw in the current. So my advice, listen to my advice, start at the biggest cell. The biggest cell is the 20 volts. I'll start here. So I'll call this one I1. I1, I1, I1. Now what happens here? It splits into two. So this way I'll call I2, and down I'll call I3. And here is I2, and here is I3. And then what happens when it gets back here?
Back to our.
It goes back to I1. So here, use the, which rule should I use here?
Junction.
Yeah, junction. Use the first law. So, Grace, can you give me the first law here? It would be, what current is going in? What's going in? I1. And what's next? Plus or minus? Mm-hmm. Mm-hmm. Focus, what's the problem? Minus I3, because I3 is also going out and out. I1 is going in. Equals 0. How many loops could I make? Nope.
Loops like 3.
3 loops. So look, these are the 3 loops I could make. I could go around like this and up, or I could go around like this, down, or what's my last loop I could make?
Only here.
Yeah, I could also just go around like this. So I have 3 loops I can make. How many equations do I need to make?
Correct. 2 more.
2 more. How many more could I make?
Like
3 more.
3 more.
Yeah, but I don't need to. I only need to make 2 more different equations. All right. So Amanda, you're going to help me make the loop start in here. We'll start the loop here. So how much voltage do I get from this one? Please. Right, Amanda, how much do I have at the start? 20.
Okay, go on.
20. And then I continue over to here. So now I have a minus.
10.
What's the voltage here? You know, Karar, what is it?
10 I want.
10 I1. Yeah, so we'll let Amanda do the next one. 10 I1. Now I'm going to take this loop around, 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 up here. So what happens to my voltage here? No, the voltage is just 10. Add or subtract? Plus or minus 10? Which? Plus or minus 10?
Why?
Nope.
Minus.
Minus, because this battery is the wrong way. This is plus and this is plus. They're the wrong way. So the voltage goes down. So it's minus 10 here.
Equals to 0.
Hang on. Minus 10. And then goes back to the start. Equals 0.
Can you get this slope, please?
Yeah. Start at 20.
Okay.
And as you said, Karar, minus 10 I1. And then here my voltage decreases by 10 because this is a 10 volt cell.
Okay.
Placed the wrong way.
Why didn't you choose the 5 volts?
I could have. It's my choice. I can choose any loop. You want to choose the 5? You give me the 5. This is Carrar's loop. Alright, Carrar, start at 20. 20, and what happens when I get here?
Minus 10 A1.
Minus 10 I1. And then continue around to here.
Yes, 5.
Plus or minus 5?
Minus.
Plus.
Why?
This battery is the right way. This is negative and this is positive. The negative matches up with the positive here. Remember, for batteries, we have to have the positive go into the negative if we put them together.
Positive or positive?
Minus. Yeah.
Is minus.
Yeah.
Positive and negative
It's
is
plus. Yeah. So plus 5 equals 0. Yeah? Oh, sorry, that's, yeah, no, that's it. Yeah.
Why did you go minus 10 I eliminate 20 and then
Why didn't I what?
in the second the
Yeah.
substitution?
Yeah? It's 20 minus 10 I1 plus 5.
So minusing the R in from the I.
This one? What are you asking me? Now, sorry, let me just write that one again. Yeah, that 20 minus 10 I1
Okay.
plus 5.
It's B is equal to I R and
V equals IR, yeah. Now I notice if you look, there's a problem here. It doesn't look like I get the same answer for I1. Now the reason for that is because I just made this example up. So it's not going to work because I just imagined the numbers. This is why, yeah?
No, different question.
Yes.
I1 minus 1 is if it's plus and plus,
It's minus.
it's why I1 minus I2 plus I2.
Here? Yeah, this is because it's going in and this is because it's going out.
Yeah?
Yeah.
No,
Are you sure?
no, nothing.
Now, are you sure?
Yes.
I can do more examples. Now, if I was, these is not a real example because you notice that this one here and this one here gives me the different answer, which it shouldn't. Now, the reason for that, listen please. The reason for that is because I think for this circuit to work properly, I should have put a resistor here and here as well. Okay, so if I had resistors here and here, it would work, but because I don't, it's messed up. But I just made this up. I just want to practice the loop rule, that's all. I'm going to do one more practice. KJ, you're going to give me the loop here, this one. Okay? So which battery do you want to start with? Which cell? I mean, the 10, you're right. Start at the bigger one, usually. Okay, so we start at 10. Can you look up, everybody? Look up. We're going to make a loop going around this way. Okay, so we start at 10, and then when I get here, what happens?
Minus.
Oh my goodness, no.
That's
Plus 5, because it's plus with minus. It's correct. Yeah, now you can see why this is wrong. Because when I get back to the start, it should equal
10.
0. But it doesn't equal 0. What does it equal? 15. So this is why I'm saying it's not a real example, because I forgot to put in some resistors here, okay? But I just wanted to practice
That's
making the loop and making the junction. Let's do another practice.
The loop is the most important.
The loop is the more difficult one. Let's make a loop here. Okay, let's say this is a 10. This is a 2. This is a 10. Yeah, okay, this is 5, and what else will I put here?
6.
9.
A battery or a resistor? Pick. Resistor of
6.
6. And I need to split it. Let's split it here into 2. Ooh, and let's put a battery here. Yeah, and we'll call this battery a 1. Alright, so here this is I1, and what's here? I1, I1, yeah. What's, here is I1. Okay, so here there are 2 different currents, yeah? I2 and I3. But when they come back together up here, it's I1. Alright, so how many loops could I make?
3.
3 loops.
3 loops, yes.
Okay. So, Sohi, can you give me the first law here at this junction? What's going into the junction? Which current is going into the junction? Which one? I1 is going out. I1 is leaving the junction. What's going in? It'll be this one, wouldn't it?
Yes,
And
this
this one here.
I-
Yeah. I2. Yes? Yep. Or I like to say minus I1 equals 0. Yeah. Okay. Now, Karar, do you want to give me a loop?
Yes, I will.
Which loop? You pick. I'll let you pick your loop. Where do you want to
The
start?
biggest loop, the
You're going for the
biggest loop.
biggest loop. Okay.
Yeah.
So
Yes.
we'll start at 10.
Yes, 10
Okay. Wait, let me write it down. 10.
minus
Yeah.
minus 2I1,
Yeah.
2I1
Yeah.
plus
Plus. Yeah.
5I1.
No, just 5. The voltage is 5.
Okay,
Yeah.
okay.
Which way are you going? Left or right? Choose.
I will choose resistance.
Okay, go left then. All right. So
Okay.
what's next?
6I2,
Plus or minus?
this way.
Yeah. Think it.
Well, it's not battery, it's resistance, so
Yes.
it is plus.
Minus,
Minus.
like with this one. Yeah. 6
Minus
I2.
I2.
Yeah.
That's all.
That's all. Equals 0. Yeah. Yeah. All right. Okay. We're getting the idea of these now. Yeah. All right. Yes. Sohi, tell her. She gave it to me. Go on, explain. Your English is good. Don't be shy.
She was in England?
Blur on.
Oh yeah, you were in England, weren't you?
Yeah.
Yeah, go explain in a British accent then.
What a bit of tickle kit.
Shh. Let's not forget KJ's law of retribution, okay? 1 sec. So explain, why is it I2 plus I3?
In that junction,
Yeah.
nothing. Going into the junction is I1 and I3.
Sorry, you said the wrong number. Going into the junction is I2. And
I2
I-
and I3.
3 is going in.
And going out is I1.
So that's why these are plus and this one is minus. Yeah? Okay, Grace, you're going to give me a loop. Which loop do you want to give me? So Karar gave me this loop. He went this way. So you have a choice. Do you want to make this loop? Or do you want to make this loop? First or second? Second, the smaller one. Okay. So where should you start?
Going in.
Yeah, I mean, where should you start? Should you start here or here?
I3.
Start here at the cell, yeah. So what do we start with? Mm-hmm. 1,
1.
yeah. And then we'll go around. So we'll go this way.
1.
Take your time. No, that is okay. Who can tell me what's next after the 1? I start here at the 1. What do you think? Minus 6 I2 equal to 0.
Okay, can you just make it the other way around?
Wait,
Like this?
go the other way?
Yeah, the other way.
Wait, hold on a second. Now, in fact, this is wrong.
Oh.
Now, why is it wrong? There's a mistake in it.
Just wait a second.
Okay, this is I3 and I2.
No, this is okay. Yeah, this is 1 because there's a 1 here. And this is 6 I2 because it's 6 and I2.
Then you need I3.
What's I3?
No, but the current here is I3. But the one that's going in the resistor is I2. That's all you care about for here.
Yeah, it's okay.
So this is 6 I2.
No, I mean 1, which is the voltage, 1 minus 6 I2 minus I3.
No,
Why?
because you add voltages. I3 is a current. These are all voltages. I1 is a voltage and 6I is a voltage. Yeah.
Can you check the blur is
Oh, it's a little blurry? Any better?
Yeah.
What's wrong with this formula? Anybody spot the mistake? No. The mistake is... Nope.
Don't guess.
This should be a plus. Because, look very carefully. You travel this way around the loop, yes?
Yes.
So you are going down. But the current here is going up. So this is the wrong way. So instead of being a minus, it's now a plus.
Now is the number?
Now this is correct. 1 plus 6I.
But if you're going the other way.
No, but this is the thing. You can go this way or you can go this way. So for example, if we go the other way around the loop, watch. If I start here and go this way around, what do I start with? Minus 1 because I'm going the wrong way through the battery. And then here is minus 6 I2 equals 0. But
Oh, because of
minus 1? Minus 6 is right because you go through the resistor and you lose. Like here earlier, when we go through this one, we lose. See, minus. So when I go this way around, go up, I lose. I'll draw it on the side. Look. Watch carefully. Resistor. Alright, so you have a few choices. The current could be going this way. Second choice. The current could be going this way. Then there's a third choice. Third possibility. And then fourth possibility. So look, if I start here and go to here, so hang on, let me write, I'll write start and end and go this way. Here I lose, so it's a minus, because you go through a resistor. If I start here and end here,
Plus.
this one is a plus, because you're going the wrong way. This one here, if I start here and end here and go this way, plus or minus.
Minus. Plus, sorry.
And if I start here
Lose.
and go here,
Can I just try this?
yeah, this will be useful, will it? Yeah.
Is the same for the battery?
And then I'll do one for a battery as well for you.
This will be.
Yeah, so if I have like,
This is for resistance.
yeah. Start and
This for the loop rule.
yeah, and start, and start.
Okay.
Okay, can we look at the battery?
No, please,
Mhm.
just a minute.
Okay, now the battery.
Yeah? Look at the battery. We're just waiting for KJ.
No.
Yeah? So look, I start, look up everybody,
Here.
I start here and go through this battery. Do I get or do I lose voltage?
Get.
Get. I start here and go through the battery, lose because I'm going through it the wrong way. I start here and go through the battery.
Get.
No, lose. I'm going the wrong way through the battery. And here I start here and go through the battery
Get.
again. Yeah.
Yeah.
Confused.
And you get used to it.
Really?
Yeah, trust me.
Okay.
When I first started teaching physics, this topic was my worst topic. I hated it.
But you have a degree.
No. I had to. Once you do these like 100 times, then it becomes your favorite topic.
Okay.
I like it because it's like a maths problem. You make the equations and then you solve. Yeah? Can I go back to the slides?
Just 2
yeah.
minutes.
Yeah?
It go wrong way, so it's plus.
Here,
Yeah.
we're talking at these. Which one? A, B, C, or D? It's plus because we start here and go here, which is the wrong way. Yeah? Can I go back to the slides? Yeah. Okay, so let me see. Here's another question. Now, just everybody chillax, alright? So, no, don't draw yet. There's plenty of time. We just want to do this one last example, okay? But we'll take our time. So here's my diagram. So just so you're clear, there is 6 volts here, yeah? There's how much here? 12. This is 4. This is 4. This is 16. Now, here we call this one I1, and here this one is I2, and when they come together, this one here,
R3.
I3. So you have 3 currents. Yes? So what I want people to do, just wait. First, you will draw this, and then when you draw it, I want everybody to use the junction rule at B. So use the junction rule here at B. Okay, so now I want you to draw and do A.
So at B, either I go right or left. I choose.
No, junction rule, not loop rule. Junction rule. First law.
I forget that.
actually, yeah, this question is a little bit more difficult. So just delete that symbol E1 and E2. Well, I mean, you don't have to delete it, Fahad. No, it's actually okay. E1 is just the voltage of the battery, but you can see I wrote down that it's 12, so. You don't need to write the questions down, that's okay, Sophie. All I need you to do is just make the equation now at the, can you see the B is up here? So give me the junction rule at B. You done that, KJ? Please take the pencil out of your hair, please. Have you done this? No? You want to go? You go home soon, don't worry. Chemistry? Keep forgetting your chemistry.
I
Oh,
hope.
and now you'll have you're going to have more extra chemistry, aren't you?
No.
No.
No, but we have, in EACP we'll have, instead of June we have now Marine.
Okay, so let me rephrase that. You will now have more Lorraine, Yes.
Yeah.
who is your chemistry teacher.
Yeah.
So it's like you have more chemistry,
Yeah.
Yeah.
But we don't see her every day.
Once
unlike me.
twice a week,
You only see her twice a week.
or EACP.
Oh no, but I mean in total.
Oh,
Total every day.
Every day.
No.
She said not every day.
not every day. 3 days a week.
True.
Monday we have chemistry.
Yeah.
Tuesday we have ESAP.
Yeah.
Thursday we have chemistry. Tuesday we have Thursday. Thursday no.
You missed Wednesday.
Wednesday, Tuesday, Friday.
Yes.
Chemistry.
So you have her every day.
No. Yeah.
Now we'll have every day.
Now you will have her every day.
Doesn't need to check every day.
Okay. Who has the junction rule at B? Sophie, did you make the equation? No? You know how to? I think you do. I believe in you. Right, what's the junction rule at B? Taken. What currents are going
Every day.
every day?
I1 and I2 is positive,
Correct, I1 and I2 are positive,
and I3 is negative.
I3 is negative. So did you hear Tekken? He said it's I1 plus I2 minus I3 equals 0. Fahad, I would like you to use the junction rule at E at the bottom.
First
Yeah.
one.
Question? Yeah?
Like the same thing when I wrote I1 plus I2 is equal to I3.
Yeah.
Same.
Yeah. So what are you asking me?
I don't really understand that.
Do I have to put all three values in one cell?
This is the normal way to do it, yes. Yes.
So where's I2 here?
So here it is.
Yes, I know, but
I2 is going in, I1 is going in, and I3 is coming out.
so can you give me the junction rule for B or anyone?
Yeah, well, Tekken did B, and now Fahad's going to do E. So what's the junction rule at E, Fahad? What's going into the junction?
I3,
And what's coming out?
I2 and
One.
One.
So I3 minus I1 minus I2
Is equal to
equals 0.
Can you repeat the B, please?
Fahad will.
B.
Fahad will.
I will do E. I want B.
Oh, so you mean you want A?
B. Yeah, it's A, but I will.
Yeah. So
Junction
Tekken will repeat the A.
Taking, can I repeat it, please?
I1 plus I2 minus I3 equals 0.
I1 minus I2.
No. Say it again, but a bit slower, Tekken.
I1 plus I2 minus I3 equals 0.
Okay, so can I say for B,
Yes.
I2
Yes.
minus I1?
No, you should say what Tacken said. It's best. All right. Now, Grace, those two equations, what have you noticed about them? Look at the two answers the students gave. The first answer and the second answer. Are they similar? Are they different? They're similar. Are they the same?
Yeah.
Yes.
They are the same. Yeah. Okay. Amanda. Can you make the loop for ABEF? ABEF is this loop on the left. Can you make the left loop? Okay. On the left. ABEF. Okay, so everybody listen to Amanda. Where will we start, Amanda?
E1.
Yeah, the 12. Yes, E1. Yeah. So, listen.
Okay.
12. What's next? 4I1. Plus or minus? Yes. Plus or minus?
Plus.
No.
No,
Minus.
minus.
So, listen. 12 minus 4I1. Okay, and what's next?
Minus.
Yeah.
16 I3.
Correct. Minus 16I3 equal 0.
0.
So write that down. 12 minus. What's wrong? I know Chinese. I1. Yes, I speak Chinese. Yeah. 12 minus 4I1 minus 16I3 equals 0. Did you write that down?
Yep.
Okay. KJ, you are going to give the loop CBED. So this is the loop on the right. So where will we start? Yes.
The back or
This one? Yes. KJ, go ahead where we start.
battery.
Yeah, so what do we have first?
6.
Write this down. 6. Next.
Minus 4I2.
6 minus 4I2.
Correct.
Mm-hmm. Next.
Minus 16I3
Yes.
equals 0.
Yes. 6 minus 4I2 minus 16I3 equals 0. Yeah? Okay. We'll give the difficult one to Grace.
No.
Yeah. Ah, yes. It's good for you. Right, Grace, you are going to give us the loop that goes around the outside. The big loop. Yes, I'll wait. There's no rush. The big loop. Yeah. So where do you want to start? Good. So listen. 12 minus 4. For what? No, you're going too fast. Start here. 12 minus 4. 4. Help her out, Yami. What is it?
Oh, 4 no.
Yes.
Yeah.
4 what? I1. 12 minus 4 I1. Now continue here.
Plus 4 I2.
Correct. Plus 4 I2. Oh, no. Take your time. You can tell me. Minus 6. No, just minus 6. This E2 is not anything. minus 6 equals 0.
What about,
No more resistors. Just goes around. Equals 0. So, did you hear that? It is 12 minus 4i1 plus 4i2 minus 6 equal 0. Yeah. Now, look at the three equations we just made. The one Grace did, and then who else did the other one? The other two, I don't remember. Are any of these last three equations the same? The last three. So where's Grace's one? Here, and where's the other two? This one and this one. Do you notice anything about them? I think two of them might be the same. This one has I1 and I2 in it. Are they all different?
Yep.
Yeah, okay. Now, this is just to make my point again, that you usually need the junction rule once, but the loop rule you could need many times. Yeah? The last part here is choose any three equations to solve. So which one should we use? Well, we should definitely use the junction one at the start. Which one was that? That was I1 plus I2 minus I3. What other one should we use?
The last one?
The last one... We could. I suppose it doesn't really matter. This one has I1 and I2 in it. This one here has I2 and I3. What's this? Yeah, I think I would use the these two. The ones in, let me see, D and E. Because I like that in D and E, that you have the I3s here you could cancel. But it doesn't matter. You just need to use tree, any tree.
But the junction rule should be included, right?
Yeah, usually. So what we'll do is let's solve them and finish. So Sohi, can you just give me the three equations I said? What was the first one? I1?
plus I2
Yeah.
minus I3 equals 0.
Yeah, now I'm going to change that into x plus y minus z equals 0. Okay, what's the second equation?
12 minus 4I1 minus 16I3 equals 0.
Okay, I'm going to change that into 4x plus 16y equals 12, and I'm going to change that into x plus 4y equals 3. Make it a little easier. Okay, and the last equation, please?
6 minus 4I2 minus 16I3 equals 0.
Okay, so that is 4y plus 16z equals 6, or that's 2y plus 8z equals 3. So these are my three equations. What do you think would be the best way to solve them? Well, I think here, yeah, what could I cancel here? I could cancel x easily, couldn't I? So x minus x, it's not a trick question. X minus x, 0. Y minus 4y, minus 3y. Minus z, minus no z's, minus z. 0 minus 3, minus 3. So here we have 3y plus z equals 3. And here we have 2y plus 8z equals 3. Okay, what should I do next? Multiply by 8. Make these the same. So now I get 24y plus 8z equals 24. Yeah, that's it. 2y plus 8z equals 3. So that's 22y equals 21. So y, can you use the calculator, KJ? Y equals 21 over 22. 0.95 amps. So that's the I2. Okay, I can put that in here to get the I3. 2 times 0.95 plus 8z equals 3. So z equals, so KJ, if you could type this in, over 8. So I3 equals z, what's z here?
0.1375. So 1
And finally, I can take these two answers here to get the x. So x equals z minus y, which will equal 0.144 minus 0.95, which is equal to, it will be negative, yeah?
0.846.
Minus 0.806 amps. Now, and that's actually, that is, what do I call that one? X, isn't it? Which we said is, where is my pen? X, which is I1. So there's I1, there is I2, and then there's I3. Now, can anybody tell me what they think the meaning is of this because of the minus? So if I go back to my picture here, the I1 is minus. My answer for I1 is minus.
Why?
What do you think that means in the diagram?
So the direction will be the
Correct, very good. That the I1 is minus means my picture is wrong. That the current is actually going that way. But that's okay. That's fine. So it just means that, and that does happen in the exam. Note, that does happen in the exam questions. That if your answer was negative, it means the current is actually flowing this way.
Calculation is correct.
Calculation is correct. Yeah? Question? In the exam? Happens. It could happen. I did say I1 was negative, wasn't it?
No,
Wait, which value was negative?
I1.
Yeah, I1, wasn't it?
Yeah.
Yeah.
Now you're after the calculation is something.
Oh yeah, after the calculation you can see I1 is negative, which means on the diagram it's actually going the other way. Yeah? Wait, we did say I1, didn't we? Yeah, I1, minus, yeah. Yeah. I don't think there's anything else to say. But the questions here. I can't, I need to wrap it up. I'll put the video up after this. Yeah. Wait, just before you go. These are the questions here. Of course.
Yes.
You see this here? This one?
Yeah.
And this one? These are both exam questions.
You'll upload them, right?
Oh yeah.
It's on the
It will be on Google. I suppose I can't stop you. You're all excited to go off to chemistry, so we better go now.
Yeah, okay.